Okay, a little bit more discussion on how we define a system of linear inequalities this time. And we were asking, what is a system of linear inequalities? Well, just like a system of linear equations was a group of equations that gave us one, hopefully, common solution, or possibly no solution at all between sets, we define a system of linear inequalities this way. We say that a solution to a system of linear inequalities is going to be a common region in the plane where each inequality overlaps. That is, we're trying to find a region where all of the solution coordinates would be the same for each of the three inequalities. And we often try to find the coordinates that form the vertices of that solution region. I'm giving you a simple example right here. Essentially, you can see what's happening right here. We've got three equations being defined in the plane in this example. We have the line x plus y equals 4 in the dashed line. Not plus, let's try that again here. Equals 4, right? Shown right here in this line. We've got the line right here that shows y equals -1 here in the solid line because of the greater than or equal symbol. And this is the line x equals -1. You can already see that there's one coordinate where the regions meet. That's a really easy one to get. That is the point at which these two lines, x equals -1, y equals -1, meet. And of course, that would be the coordinate -1, -1. Right? So we would write that out. Here's -1, -1. Right? However, if we wanted to find these other points over here, we would have to find the points of intersection of these lines. So for example, we might try to find the point of intersection of x plus y equals 4 and the line x equals -1. Well, if x equals -1, then all we really have to do is substitute in -1 for x, find the y value that goes with it. In the second equation, x -1 plus y equals 4. Adding 1 to both sides gives us y equals 5. And it looks pretty obvious that's what's happening right here, right? Graphically, we can see the point -1, 5 defines this vertex. And our third vertex right here would be found where y equals -1. Well, lo and behold, that's pretty much the same deal, right? We're going to find that point to be 5, -1. Right? So our solution region is the region formed by the inequality x plus y is less than 4, which would be everything shaded down here if we used the test point 0, 0. The line x is greater than -1, so everything to the right of x equals -1 in the plane. And y is greater than -1, so everything greater than y equals -1 in the plane. And all of those overlap in this shaded region shown. So now we want to define our solution to a system of inequalities. And so what we're going to do is if we want to find the solution to a system of inequalities, what we're really going to do is we're going to look for a solution that involves, let me get a good color here for us. We want to define a solution that involves the overlapping of these regions. So what we're going to do is we're going to find the region defined by the intersection of the two lines and finding the region, and find the region where the linear inequalities overlap. Okay, so that's our goal right here. Let's look at this system of equations. We've got 3x minus 2y is less than 12. X plus 3y is less than 6. So I'm not going to go through all the details of graphing this one, but let's just run through the example so that we can see the two lines being graphed. So our first line, 3x minus 2y is less than 12. Let's plot that. 3x plus 2y. 3x, get a nice pen going here. 3x minus 2y is less than 12. I'll put that one in blue. So we're going to graph that with 3x plus 2y equals 12. Letting x equals 0 gives us y equals 6. So that means 0, 6 is one of the points along this line. And of course, letting y equal 0 gives us x equals 4. So that would be the point 4, 0 somewhere along this line. So if we wanted to graph this line, we would plot this line this way through these two, but let's change the properties of this line, right? So we can get a, because we're using greater than, we want to make sure we've got a dashed line. So we use a dashed line, and since it was blue, that's the color we'll use for our line as well. Okay, so that's our one. And now if we want to graph 3x minus 2y is less than 12, we have to shade in the appropriate region of our graph. If we put in 0, 0 right here as a test point, our test point at 0, 0 gives us, let's see, 0 minus 0 less than 12. Yep, that's true. So it's going to be everything on this side of our line that would be shaded in. Okay, let's try a different one here. Let's put this one in green. We've got x plus 3y is less than 6. So we want to graph the line x plus 3y equals 6 and use a dashed line for it. If we let x equals 0 and solve for y, we're going to get y equals 2. So that's the point 0, 2 right here. And if we plot y equals 0, we're going to get x equals 6. So we're going to put the point 6, 0 right here. And we're going to plot that line. So let's get a nice line here. Again, starting at 6 and just working our way out to the left, we can see what's going to happen with it. Let's go ahead and change the properties of the line so we can tell one from the other right here. So this is going to be a dashed line as well. And let's make it a nice green here. There we go. Beautiful color. Okay, so which side do we work on? Well, let's see. If we use our test point here at 0, 0 again, does that work? 0 plus 3 times 0 should be less than 6 if it's true. So everything on this side of the line works. And so what we're going to find is that the region where these two overlap will look like this. And you can see that we shaded everything that is actually to the right of this line and below this line, so it looks like we've got a region that's kind of defined by these two lines intersecting one another. The other question, of course, is where do the two lines actually meet? Well, right here we should find this coordinate right here. That's going to be the point where they intersect, and we would actually solve the system of inequalities. 3x minus 2y equals 12, and x plus 3y equals 6. Let's see, what could we do right here? Well, we could multiply the bottom one by 3 right here in order to do a subtraction. So we would have 3x minus 2y equals 12, added to negative 3 times x, minus 3 times plus 3y, that's minus 9y, equals negative 3 times 6, that's negative 18. And let's see what that comes out to be. Negative 11y is going to equal negative 6. So y is the coordinate 6 over 11. Of course, we would substitute into one of these two equations to solve for x. I'll go for the second one because it seems to be easiest. X plus 3 times 6 over 11 should give us 6 as that coordinate. That's like saying x plus 18 over 11, 18 over 11, is equal to 6 over 1. That would be 66 over 11. So we would subtract 18 over 11 from both sides of that equation to give us x equals, let's see, x equals, I'm sure x equal here. X would equal 66 minus 18, so since it's an 8, 5 minus 1 is 4, so 48 elevenths would be our answer here. And it's okay to leave fractions in improper form. I would write right here as my coordinates 48 elevenths and 6 elevenths for y. Funny looking point, but that's our intersection right there.